Welcome to Breaking Your HTTP API to make them stronger. On this session, I'll give you share with you some of my experience that has shaped a bit of my career with a couple of experience, one bad and one good, that I'll share later with you. I will not ask which one you want to hear first, because that's already written. But first of all, who am I? My name is Jose. You can call me Jose, but full name is Jose Luis. Last name is Latorre. My Twitter handle is JOSLAT, which comes from my name, first three letters of my first name and last name together. Also my GitHub, so if you want to see what I'm coding on the weekends. And that's also my cat, Whitey. She adopted me like 2 years ago, and she's helping me on this presentation, kindly, and also taking my space in the sofa, as you can see. But well, that's what it comes with a cat, right? Who has a cat here? Yeah, you know what I mean. All right. I'm also a KC champion since 2 years, and I'm a Microsoft MVP since last year, but I was also before for quite a bit. So I like sharing my knowledge. I like to share what I know. I think it's fun. It makes you try to speak better, because when I started, I was really awful speaker. Now I think I'm hopefully decent. You will tell me. And I'm also leading a user group in Zurich, which is the Zurich.net user group. It's online as well. So we are doing the events hybrid. So whatever we do in person, from this year on, we are streaming. So you're all invited to attend, if you're curious. And again, I'm using this feature of PowerPoint, which is pretty cool. Donna Sarkar told me before how to do that, so thanks, Donna. She's in the other room talking about AI. What else? And let's get started. But before, I also work as software developer and developer community lead at Swiss Life, where some of my colleagues are here. I don't know, Gabriel or Martin in the room? Yeah, okay, good. Then, what's on for today? I will make a bold statement, right? It's breaking your API is sometimes not the best way, but the unique way to find these hard-to-find issues that you probably will find in production later on when you are already delivering, and that's terrible to find. And it's a fantastic way to get them, your APIs or applications, into proper shape, and then improve them even further. This can save your company, us literally, in a big way, because these kind of things, you release something in production, you find an issue, and that issue can take months or years to fix. I was in one of these things. And later on, once it is fixed, it will simply make your application better and better and better, but also give you the guarantees that your application is fit for production. And whatever you're going to deploy is not breaking anything. Of course, you may think, we have already unit tests. We have already some kind of load test. Who is doing load tests here? Yeah, one hand. I'm doing that too. Not everywhere, though. Wherever they let me. Even I'm spreading these and trying to convince them. But, you know, Murphy lives, right? Already. This is about breaking things here. Have Whitey helping me. It's doing what a cat does. You put the API or the task, and you push it. You test the limits of when it will break. And then, as a good engineer, you fix it, redeploy. It's a cycle, right? That you should repeat over and over. It's kind of the concept of testing, but applied to performance testing and looking to stress the things out, and you should do it, really. It has many benefits, like, first, identify things that otherwise you will not see. It's almost impossible. If you have something which is an API and you test only one request, what if you have 100 users, or 1,000, or 1 million? Makes sense, right? If you want to check the scalability, then testing one user is not a good idea. It will reduce, if you do it optimally and optimize, your infrastructure costs. And you will get not fit to function, but fittest, and have a lot of better quality in your code and your services, and not to mention reliability. That's a given. I mean, the first thing you will do is put that, try that, and then you will find issues, which you will quickly fix, and then focus in throughput. And your developers will also grow And more important, have fun. I never had as much fun as when I was really digging into the limits of a system. You know, when you put your hacker head and investigate it, it's really engaging. I really like that. Even sometimes it got me in a wrong way. So a company used me as the fixer. They put me the hat and was sending me to several projects that were not that good. And they were not paying me for that. But it was fun. I learned a lot. And also, it will make you, more importantly, save money. A lot of money. Really a lot. And I'll put an example, right? This graph that you're seeing here shows the relative cost when you're in requirements. If you see a problem or something is not fitting, a requirement doesn't make any sense, which can happen pretty much, you can fix that. Or in the architecture, then the coding, and yeah, testing, and deployment maintenance. But honestly, here to me what's wrong is that coding and testing should come along together. And that's a very strong statement. And then, if you find it here, yeah, well, it can really cost skyrocket. It's a logarithmic escalation. This comes from NSA, and also from studies made by a lot of companies. IBM supports these, and Microsoft as well. So it's true. And also my experience tells me that. My experience is basically once upon a time, and I will stop this so you can look at me. I was in a project, and that project was already 7 years in advance. And had a lot of people, like 80 persons, up to, it scaled up to 120. I'm talking about only developers. And the company invested a lot of money in there. It was for a big pharmaceutical company, not tell the name, but if you look at my LinkedIn profile, you will figure out. And almost when we were ready to launch in production, we realized, okay, the backend is dying, the database is dying. We had a huge bottleneck in the database and in the backend servers. We tried to improve the throughput, but did not work. And the only thing is, okay, we delayed the product launch for 1 year. Think about the money for that. The company put one dedicated architect to solve that problem or to mitigate it. And that architect was external, was a hefty cost, quite a lot more, and that was more or less 1 year and 2 months until the product was ready to be launched. So that was the delay and the cost additional. And one full team of 6 persons dedicated almost 2 months to mitigate that. That in total is more than $1 million. And of course, that without counting the time to market. That's a bit of money, right? And then the other story is the good one. A couple of years later, I was a performance test lead in a laboratory middleware, which is kind of the box that you put in the middle of a laboratory. Everything is connected these days, and tells one system asks you, hey, what do I do? What test do I do? You have to do a blood glucose analysis, right? And they have to do this very quick. And then there goes another machine and does the final storage and gets the test, and it's managed by this system. This system had to handle like a lot of load. This was for a big factory system in South Africa for blood banks. For example, in Switzerland, there is a Lucerne hospital. They handle about 12,000 samples a year. They have like a full room dedicated, plenty of instruments dedicated to that. So this system had to handle 64,000 samples per day. That's quite a lot more, right? Then what we did, or I put, is a strategy that fill up the data since day one. Whatever we could do already, we created the data with some SQL scripts. It was SQL Server. And then we reproduced the flow of the application that we could test and simulated it around the system. That worked really well. So let's say that in 1 month of doing that, we detected, guess what, database bottleneck issue, similar to the one in the other project. Time to fix it, less than 1 week. One only person. So, yeah. It's quite a difference, right? That felt good. And we repeated that for like 2 times more on this project. So that's the lessons I learned. And since then, I try to apply that to projects that can have this criticality. I think it's quite important. But let's jump into concepts. So this is about why you should do that and why it matters. Mostly the money part, and also to have fun. I never had as much fun as I had there, because I could play different roles, the evil breaker and then a bit of investigator. The concepts basically is, what we have to do is break the API. What does it mean? Breaking the API means that we have to get it to not execute anymore. So we exhaust all the resources for once, either it's memory, CPU, hard disk, whatever, network, it can be anything. Or we make it violate any of the SLOs, service level objectives, right? If anything here is broken, then API we can consider is dead or broken. The concept of breaking the API is use performance tools to do that. In this case, I use K6. I'll talk about K6 in a moment. So the idea is to replicate real conditions or hardware. In the example, what we did before, on the first time, on the laboratory middleware system, was we try a normal usage in one shift of 12 hours. But the next test, the system was so good that we were doing stress tests. So we were doing all the throughput in 1 hour only. That accelerated the testing drastically. Then you go into investigating. You put the Sherlock Holmes hat and pipe, or the mustache of Poirot. I don't know if you like Poirot, I love it. So you use your gray cells, you investigate, you dig in. That's quite interesting as well, and gets you to really know the tools you are using. And it's pretty cool to do that. And finally, you improve. Once you understand something, it becomes easy to fix. So you play these crazy scientists. I don't know if you know this movie. It's The Little Frankenstein. It's a pretty old movie, but I love it. If you can watch it. It's pretty cool. I love it. And then we go to the tools that I'll show you today. One is K6. Anybody has used K6? 1, 2, 3, 4. Okay, that's good. You like it? Yeah, I love it. So it's test as code. I don't know if you are using any other thing for tests, but come on, this day and age, you want the test as code in a way that you can understand easily. So for me, K6 is easy to understand. If anybody that uses K6 doesn't think the same, please let me know, stand up. I love discussions. And it has a really great set of features. It's really flexible. It allows you to shape a real system load very, very well in a way that you can read the code and understand what it's doing. So today, I will not do any intro to K6 and show you some scripts. And you will naturally determine more or less what it's doing. Otherwise, complain and say, hey, I don't get it. So it has a very sweet performance ratio. As it's tests code, it integrates really well with anything DevOps friendly for continuous integration, delivery, and testing on the cloud. You can do that. We are doing that in the company. So in fact, I have a project in my repo that I shared before. I will share the slides later on. And you can dig in and use it. It's kind of a template for a multi-scenario in K6, ready to be integrated with any pipeline in DevOps in the cloud. And you don't need a client. So it's pretty cool. This is from some years ago. Now it has improved. But this is RPS, stands for requests per second. And the blue is, in this case, 11,300 requests per second, and then 67 megabytes of usage for executing that load, which is pretty good. 2 years ago. Now it has increased. The maximum load before anybody asks is about 400,000 requests per second. Of course, you need a really, really powerful machine for that, but that's at the moment the theoretical limit that you can do. And you can also use it on the cloud, or you can use the open source, completely free client in your computer or in your Kubernetes cluster. where there's open source for coordinating different clusters of pods. So you can go any high as you want. Then we have our victim, the API. In this case, we are using App Service. I don't know if anybody is not familiar with App Service. Okay, App Service is one of the many, many, many services from Microsoft Azure. And it's a smart API meant to host an API that you can code in many languages like .NET, C#, Python, or any other languages. You have quite a lot. And also you can run in Windows or Linux and deploy to the cloud. It is secure up to a point, then you can extend the services of security, but that's up to the Azure platform. I'm not going to jump into that. It's multi-platform, multi-technology. It enables auto-scale and load balancing, so it's completely safe for very, very large productions and deployments. And it has a lot of features like integrated monitoring, logging, something called application insights that I will show you in a moment. And it's integrated with CI, CD, Azure DevOps, and application slots for deploying. It's a pretty cool service. And then the environment. That's where the crime will happen, or the crimes, because I have like 3 stories to tell you. It happens somewhere in the Swiss Alps, because I work in and live in Switzerland since a few years. So in the Swiss life, we have an app service that's called Heidi. No, not really, but. And we have a test VM, because everything we will do in the cloud. And I wanted here the lowest possible latency to be one as close to each other. And for that, I put a virtual network and a network security group and connected them through a private endpoint, which makes the app service private. So the addresses that I will show you, you will not be able to access, sorry. And I connect through Bastion, which is a secure way to connect to a VM in the cloud, which is quite better than RDP, which is quite considered today as a hole in the security. And then I put some other services in there that I need that I'm not going to dig into them. Last but not least, I put K6 open source in the test virtual machine. And I enable K6 Cloud. To be clear again, K6 open source is free. Anybody can deploy it and use it. Multi-operating system runs anywhere. But K6 Cloud is not. If you want to see some metrics, some nice graphics, you need K6 Cloud. And we go with this to our first case of the evening. We can consider already the evening, which I call it the memory cobbler. I asked ChatGPT, I think, not Dolly, to generate a cat. And yeah, that's what it generated. That's not my cat, by the way. I don't know him. I would not let my cat be like that. This kind, what we are looking now is kind of application that eats a lot of resources, more than it should, and keeps growing and growing and growing and growing. Probably you have seen that in the shape of a memory leak, right? Who has been here in a memory leak? Me, 1, 2, 3, 4, 5, 6. Whoa, quite a lot. You know the pain. Sometimes it's easy to find, sometimes it's not. So I'm trying to do a demo and show you a bit what is going on here. And if the connectivity doesn't work, I have it scripted. So yeah, we can see that. So here I have a resource group where I put all the resources. I have this API in network, not Heidi, sorry. I thought of the name later, but that could be a good name. And yeah, I configure application insights, some other things like the app service requires an app service plan. And here I have the virtual machine for testing, which is API test VM. Here is the API app, which at the moment I have deployed to a standard service whenever it wants to load. All right, if this doesn't work, I will switch. I may have lost connectivity. And still not working. And then in the VM, I have installed the Visual Studio Code, which is great for demos. I lost my laptop. I don't have to do anything. And I also have deployed my slides there, so I could do anything in there. And here is a K6 script. In fact, I think the best one is I show you this. You can figure it what it does, right? I'm doing importing some, using in .NET, I'm importing K6 HTTP to use HTTP functions. Oh, yeah, of course. Big enough? I will simply smash this. At the bottom is good? Yes? Perfect. So I'm making here a call to HTTP GET for this. This is an API in K6, ready for test, and sleeping and executing that. This is by default orchestrated by a concept in K6 called a VU. VU stands for virtual user. So if I go here and run it, which is done by K6 run, this is 01. I press the tab, hope it works. It does. And here, let me make this bigger. We get the K6 results. And make it. OK. I will do that again. This you're seeing here. Basically, is that's maybe not mine. Yeah, I took Michael's, the previous speaker. So here we can see the environment a bit below where we are executing. Here we can see the progress, the number of views of virtual users, date, and some statistics like data received, sent, different kinds of parameters for HTTP request. And here is the one we are more interested, the duration. In this case, we have like 1 second, 1 second, 1 second. Everything matches. Here we have a minimum, average, and median, maximum, and 90 and 95 percentile. It's pretty cool. You can define them, and below you have how many iterations. Iteration is how many requests you did, and the maximum views used. So it's pretty cool. And going back to the test and memory gobbler, I will go, oh yeah, now we can see it. So the standard is the one I have, which is one virtual CPU, 1.75 gigabyte, not too much memory, but we don't need memory. Well, we need memory, but not in the hard disk. So we'll see what happens with that. And test machine. What we are going to do is open application insights. Should open. Application Insights is a monitoring service, part of Azure monitoring, that is specifically designed to monitor app services, right? So it matches them and enables you to watch what exactly is happening on them. So it gives you an overview, it gives you an application map. It's pretty cool if it loads on time, yeah. Which you can see graphically where we are connecting. It gives you a performance overview, and what we are going to pick is at live metrics. This is pretty cool because it's a sub-millisecond latency, so you can see what's going on, and you can see here how the system is reacting in real time. It's pretty cool. And we are going here. And we got the big mem. And if this works, K6, run. I tried that, but K6, 03, and then tap. Yes. And before I execute it, I close this so you can see the full beauty of that. And let's see if it's properly updated, because before I tried that a bit and it was not being hit. So I go to here. Yes, perfect. Beautiful. That's what I expect. You can see here in overall health, in the memory, it's skyrocketing, and suddenly, if everything goes as expected, we will see some red, a nice bright red to the right side. Well, sometimes it does not, but it will show you in a moment. Otherwise, I will skip and show you in the presentation, because this update real time, sometimes it does not. Yeah, perfect, beautiful. So we get this dreaded out-of-memory exception, which, if you have properly observability, you will see it happen, but sometimes not everything is as evil as the code I have. I mean, the more usual thing, and probably the people that raised the hand before that found a memory leak, you probably discovered that after 1 week or 2 weeks of work, something that was growing, and if you observe it, it's not really, usually it's very sneaky, these kind of bugs. So on this system, I exaggerated it to make it really noticeable. And I will skip now to the demo and skip the parts that I already show real life. And yeah, here is what's going on before. You can see that there's very evil code, right? If you know .NET, you know what I'm doing here is, okay, nasty, sneaky, very evil. So I'm creating a static list of a string that I'm adding a string of 50 megabytes every time I make a call to this. Something you should not do at the company. But in the project I was mentioning, the one before, after 3 years, there was a kind of similar bug, the same, in the screen. So we were loading styles, and the styles were loaded, not the best way, and this time you were loading a concrete screen. You were adding not 50 megabytes, 200 every time, apart from the delay of loading the styles every single time. We simply had a hidden reference to them, made by, in this moment, SAML. It was Silverlight. I don't know if anybody has ever worked with Silverlight. Rest in peace. I love that technology. I became once, like 2 years, MVP on Silverlight. So I was consulting on Silverlight. That is what brought me to Switzerland, to fix that bug, exactly that bug. So I'm thankful for the bugs, really. So I'm really happy. And yeah, so let's, go back. So you can see the problem, and fixing that is very easy. But this is the kind of things that doing this testing can help you greatly. If you really add a lot of throughput, in a REST API, you can do that with K6 or any other technology you wish. So I'm not saying that K6 is the best, but that's the one I like the most. I'm happy to discuss that afterward with a coffee. Anybody here is using anything for performance testing, which is not K6? What are you using? Okay. Oh, that's one of the biggest memory gobblers out there. Are you happy with the non-code experience?
Not really. We are thinking about moving to low-cost or maybe K6.
That's a good idea. All right. And there was another hand there? Okay, yeah. JMeter has been there for ages, so I would not call that modern, and it's bound to a UI. So mine personally, I tried that, didn't like it. Yeah, so it consumes a lot of resources as well. So if you want to do very large tests, they're going to cost you a lot. I don't know. I'm curious later, if you have experience and you run very large tests, how much the infrastructure is costing for you, if you know that. Okay, then we have the second case of the day. Have you ever had an app or a service that somebody did, but that person is out of the company and there is no documentation, and you cannot modify it, you have to use it? It's this kind of toxic relationship that I need you, but I hate you, right? This kind of thing. Well, the only thing we can do there, okay, is swallow it and learn from it. I mean, you have that in real life as well. I can say that was my case a lot of years ago, luckily. But it's the things that can be slow, insecure, you cannot trust them. Oh my God, it's depending on evil, basically. And the question today is, how bad can it be? I don't know if anybody here has a case or is having a case. In my company, for example, we're working with SAP. Yeah, I don't know if anybody is experiencing that, but it's awfully slow. I'm not saying it's bad, so just to be clear, if this is recorded, that I'd say that sometimes it's slow, just being politically correct for the recording. And you have to put some measures to that. How can this be? In this case, we have an able API that sometimes returns some errors, like 500 server error. Yeah, not the best. And the code, we managed to read the code of that. Yeah, it gets worse. So there was somebody evil and sometimes doing a random. It does a random weight, so it's not really performant. It sounds 404, 400, 500. So, and sometimes it returns, yeah, the answer to everything, right? 42 or a GUID. Yeah, not really that, right? That's kind of code that's really very bad. It can get worse. And before I jump here, I have like 2 exclusive K6 key rings that I will give to the person that responds the next question, if you've been paying attention. So the question is, what is the worst thing with this code? And sorry for behind, I cannot make it, well, maybe I can make it bigger. So I'm the first person that sees that. Is better now? Somebody? Somebody was in Leila's talk because she covered exactly the same topic. Sorry? Sorry? Sorry, what? That's HTTP client. Yeah, exactly, that's it. So, yeah, I'm still good at throwing things. Hopefully I didn't hit anything bad. So HTTP client, if you create it like that, that's something evil because HTTP client is designed to be shared. Otherwise, if you are using it like that, you will have resource exhaustion, usually with sockets. So it's called socket depletion. Even if you dispose of that, it does not get disposed right away. So if you do a lot of throughput, you will end up without sockets, which in a API is not a good idea. Oops, let me zoom over. The other question is, well, let me show you before what happens. So we have this test. This is the evolution of the test. We have this part, which we have stages. And if you follow, you can check. We have as well some thresholds that it's quite declarative, right? So we're taking 95% must be under 900 milliseconds. The rate of failure should be 90% should succeed. And then we have the stages, which basically we will have 2 views during 10 seconds, 30 seconds 3, 5 seconds 1. What do you think? It's easy to understand this test. And it shows a bit of a load that goes over and then goes down, right? If I execute this, I get these, a lot of issues, which is expected, right? The other is throwing random errors to the API and depending on something which is code, not shitty, it's code with evil intentions. I did that for the purpose of this demo, so I know I coded that. And then it looks like that. I show it in live, but you can see that, no, sorry, going behind, the errors that the dependency call are relied directly to the user of our API, which is not what we want. So, question for you is, who wants to get the next keyring is, what can we do in ASP.NET to improve that? Also, Leila, show a way to fix this. Yes?
Named HTTP clients?
Sorry?
Named HTTP clients?
Named.
HTTP clients.
Yes. Exactly. Good. Yeah, sorry, I failed. Sorry, I don't have one for you, but that was also on the spot. That's one way to do it. The also other one, if you code is running in I think it's .NET 2.1 on onwards, you can use HTTP Client Factory. Otherwise, you can also do a static HTTP client and reuse it, basically. It's meant for that, you can do that. So this is exactly what we did, and all the thing that we did is we implemented a retry policy as well. So we shield ourselves using poly. We implemented a policy, which is here, and if the status code here is, if we get an exception, or the result is bad request, or any of the cases that can be thrown, then I use this wait and retry async, back of the correlated jitter, back of v2, this strange name. This is apparently the best way to do the implementation of the retry system. This is, by the way, if you were in Leila's talk, what she wanted to implement, and she had not added this reference to this Nugget package. This is Microsoft extensions for Poly, or Microsoft Poly extensions. I really don't know now, but that's it, essentially. And then here, I'm simply using it, the HTTP Client Factory, which I created, again, before here, and I'm reusing that to create the client, and this will automatically balance everything. And then, yeah, using the retry policy to execute the call asynchronously. And the outcome, yeah, we still get the dependency errors, but we get not in our system. Still, we are not very fast, but that's the best we can do, right? If you cannot modify that. And yeah, things are not good in the test because we are over 900 milliseconds, but the times before we were 4 seconds or more, sometimes it's become better, or at least as better as we can. Make sense? So this is one of the other things that we can do to improve our APIs if we depend on other third-party services which are not that good. Other thing that we could do, and I'm not going to show it, is to do load, even the load. Are you familiar with the topic? Even the load, usually what you do is you have a facade which takes all the requests and puts them in a queue. And then you process with another client that reads the queue and is polling the evil service, keeping that under control. So the evil API, we know it's random, but what if we do a lot of requests and it dies for 5 minutes until it restarts? Then we should do, I think it's a closed open circuit, or circuit breaker pattern, that's how it's called. Basically, we are doing a concept of shielding that section of the code and evening the load in a proper way. This is a pattern used in cloud a lot of times. So if this is that we did, this retry is not good enough, we could do this load evening, or even the load, sorry, using a queue, right? And last but not least, we got to the last case. I really like it because that was my initial demo and broke me crazy for a few months. I ended up opening a ticket with Microsoft on that, and I more or less closed it like a few weeks ago. Basically, this is a murder on the API, or on the API Express. I wanted to target some SLOs that I defined for Azure App Service, and I created a CPU-bound API, which is nothing more than a P calculation, calculating the P number. That's what it's doing. It's a mission critical. I want the response time, the 95 percentile, to be between 10 and 90 milliseconds. And the clients are other APIs, and I want this to go from 10 to 250 requests per second, maximum. And of course, using app service, which I really like. This is initially the test, complete. So I'm calling this API network with this P endpoint, with similar requests. I don't want the test to break, so I could get the test to break, or not to break, but simply I put it a bit bigger, the thresholds, so I want the P95 percentile to be 550. If it's more, it will stop. And then I'm using here a bit more detailed scenario. This is key. This executor ramping arrival rate, ramping, by the name you know, it's ramp up, so it will grow steadily or ramp down, however we want. This is based on the stages. Oops, sorry. And we have a time unit start rate, which is, in this case, I'm going by rate, not virtual users. So I tell, okay, I want requests per second, purely that. I want to focus on that and not have to worry on how many users do I need. I want K6 to handle that. This is what is called the open model. This is one of the reasons why I love it. You gentlemen that are using K6, are you using the open model? This was launched last year, in mid of last year. So if the tests are not updated, probably not. Okay. So for this, I have to pre-allocate some virtual users. So it will create 500 users ready to go and do tasks. And the stages are 2 in this case. So I go for the lowest. So meanwhile, it will go from a start rate of 5 until 10, and it will ramp up during 15 seconds. And then the rest of 85 seconds, it will keep 10 requests per second. How will this go? We are still in a standard tier, and this is the test running, and this is the outcome, which I decided to put that in a slide, not to make you wait, and also not to change context too much. So it was successful, the test, but the conditions were not that hard. Everything went properly without any HTTP 200. And the request duration, well, it went up to 1.23. Oof, that's a bit too much. Even the 95% technically was successful, something was not okay. If we look at live metrics, this sub-millisecond latency thing from application insights in Azure, the load was more or less okay, and the response on the app service was good, so between 4 and half millisecond, so it's no errors. The CPU, oops, I'm pressing the wrong button. Sorry. And the CPU was pretty nice, curiously, with 10 requests per second. So then I exported that to the cloud. It's just you have to log with the token in K6 free, and you put -o cloud, and the export is going to the cloud. You can export to your platform of choice. There are a lot of integrations, and you can develop your own integration if you want. And here we can see, the time here, let me see, because it's 100 milliseconds, so it goes over 100 milliseconds, and it has a lot of spikes. So it's not really stable. I would not call that stable. So I then decided to try it a few more times, and I saw general spikes that went over 1 second. I say, okay, maybe that's not the best. I reviewed the code. The code was good, performant. I tried my computer, pretty powerful one, and without any problem, I could do like even 2,000 requests per second. So I say, okay, what's going on here? I'll try some, these app service you can scale very easily. And I tried that there with a better one. This is the performance analyzer. It showed that really, okay, this 1 second is nowhere to be seen. So I opened a ticket to Microsoft, which I escalated later on. I'll tell you why in a moment. And then I decided, okay, I will do the big test and see what happens, how it's behaved with the real load, the 250 requests per second that I should have. And I tried this. This is exactly the same. I start with 5, I ramp up the request per second to 50. I stay 40 seconds with 50, and then 50 seconds, I ramp up again to 250 and stay there for 45 seconds, which more or less is enough. You have to play with that. It's the part to, okay, let's play with it and see if I can break it. And you will. This didn't end well. So you can see that you get a maximum of 6 seconds, and P95, it was 600 seconds. So definitely, something is not good. The nice thing is that internally, the load is matching the CPU usage, which is a pretty cool thing if your API is CPU bound. So this is the kind of things that say, okay, this is healthy. There is following the pattern as it should. It's a kind of good symptom, this one. And the outcome, yeah, I still were getting some spikes. This is already a bigger tier. Then, sorry, it was the same tier. Then I upgraded to Premium P2, which has 1 CPU, 3.5 memory, and more disk space, which I don't need, but it's a bigger one. Also costs a bit more, like double. But let's see. And the outcome was a bit better. From 500, we went to 136 milliseconds. Still not what I want. And still, I have spikes of 7 seconds, which are definitely not good. But again, everything here is fine. Strange, right? And there are spikes still, like about 1 second. So what to do? Scale up. That said, this was triggered because of the response from Microsoft on the ticket from the product team. They say that, yeah, well, you know, what you're looking into there in the monitoring layer is only considering the application that is hosted, but not the host container. They didn't tell me if the host container is shared or not. Maybe they didn't want to. But the part, anybody's familiar with Internet Information Server or the host, the one which is getting the connections of requests and redirecting them to my application, that's the part that was failing there. And the response was, yeah, you should use a system with more than 1 CPU, and then you will not have the issue. That's the response, so that's why I tried this. Let's see if it works. It went well. So I went to 28 milliseconds, which before it was 130. It's a lot better. But still, I got a spike. And I repeated that test many times. Here, still, I see nothing. And I got like a heartbeat. Initially, I was calling this the mystery of the hidden heartbeat, because it's like a latency or spike of some kind, like the service was used by other people and not me, because it's not dependent on the load I generate. And then I compare. This is one thing. This I'm showing you is K6 Cloud, which you can create a baseline and set and compare every time. You can even have an API to poll it and say, okay, this is good, this is bad. You have deviated. In this case, I compare with the previous one, which use a really smaller app service tier. And yeah, the great one, if you can see that, don't know if you can see that from the backend, is a lot higher. So the spikes were a lot bigger. And here, they are not that noticeable, but still there. So I can get the results I want according to the slow, but still, I mean, if the C service is used by a business application, we are good. But if it's used by a critical system for a driving or a machinery, and we need real-time decision to stop action or not, yeah, we are in a mess. So this is not going to work. Just to be curious, I tried the bigger thing, which is kind of pretty costly. So it's 950 euros. So this can be quite a salary in some countries. And try how it goes. And honestly, it didn't get better. So not all the time more power equals. So instead of 28, I got to 27 by doubling the cost, which is not that good. Just saying before, the best or the most performant that I manage is with the standard S3. Even the standard S2 was good, which are the more cost and quite a lot less cost than a premium B2. So not everything is code, and you have to play a bit with these to really know that, at least in the cloud you do, because not everything is in the documentation. I asked Microsoft to update the documentation, put that clearly, still waiting for a response. But at least, and get to know better the app service, which is a bit the role of this journey. If you explore a thing, maybe it's not the code, maybe it's the platform, or it's a mix of things, and it can be complicated, like this was. This took like a 2 or 3 months resolution. And we managed, determined that we would use a container for this kind of real-time things, because you have a lot more control on what's happening there. In this case, Kubernetes. I'm going to go back there. This is the outcome that I already see. And my feedback to you is, do it. It's pretty cool. I hope with these 3 cases, my story, which I swear is real. You can come and talk to me later on or here on the stage. We have some minutes. But do it. It's really worth it. I mean, you can be the hero of the day and save the company. It's not that they are going to pay you. They never do. At least they didn't with me. So I know on the other case, okay, I figured out something that in other code project was detected 7 years ago and costed the company $1 million. Hey, I got a fully met. That means, yeah, you get your bonus as usual. Yeah, well, at least the project lead was happy. He invited me to a dinner. That's everything. And the satisfaction, right? And the fun to learn how things work and get to know with the internals. My other feedback is K6 and app service are awesome. At least app service for web, general web. For critical things that require low latency, you have to try it. Maybe it works for you. For me, it didn't. And then observability, looking at the different monitoring is key. In this case, I was missing a part of it, but it gives you the full history, looking from 2 points of view. In this case, from inside the application and from completely outside, from this test VM located in the Swiss Alps, not called Haiti. And that's it from my side. Thank you so much. And if you have any questions, there is something you can point your mobile there if you don't have the Slido app open already. And I'll show one more thing and come back in a second. Again, remember to give feedback, please. Feedback is important, makes us better. You know, it's agile. We get feedback from our colleagues. They tell what you can improve in your code. The same is for speaking. But hopefully, you know how it works. It's smile, smile, smile. And yeah, say nothing, please. And again, thanks to Whitey, my cat, for helping me in the presentation. And I hope it was interesting. And it's engaging you to break your API. Again, there are some stickers here, two pins here. There are like 3 pins. They are free. First come, first take. You get it. And I'm happy to get questions, either through voice or through Slido, so feel free. Otherwise, I'll make you a question. In the K6, how much throughput are you using the K6 users? Or what scenarios are you using it? Too shy. Yes?
Have you ever put performance testing actually on the database connection?
Yes. Yes, exactly. That's a very good question. K6 is not meant for database, but there are plugins that you can test on database. And so there's it's open to extension, and there's a couple of extensions to a concrete set of databases. That said, usually what I do, at least, is I mock the database service. So do you work in .NET? Yeah. There's something called Squadron, which is container-based. So it creates many different kind of services. There's one for SQL Server. There's one for MongoDB. I don't know for others, but these two are working really extremely well. So you can create real database there, and you can do the preload of the data. So you can have all the data with the scripts loaded in there and execute the code. K6 has another thing, which is interesting, which is chaos. There's a chaos extension, which is, okay, I put up this service and the other, and then I break services randomly, and see what happens, or willingly, right? So it's pretty cool. So I check it. It's one of my company. We are doing a lot of Swiss, it's Swiss software, but open source. And this squadron is on GitHub. So you can look for Swiss Life or Squadron.
How is it spelled?
Sorry?
The spelling.
Yeah, sure. I think it's better to show. Can you see? Squadron. It's this one. Good. And going back here, any more question? If you're shy, you can ask a question anonymously in Slido as well.
Yeah, by the way, the Microsoft answer, what was for the first performance issue? You said you raised the ticket for Microsoft.
Yeah, the question was for the multiple spikes, the hidden spikes. Basically, they answered that was due to having only one CPU, that the service, the hosting service, was not being considered in the memory when you look into the application insights. Which in a way it makes sense, right? Because you are doing a monitor on the app, not on the hosting of the app. But then I tried to look at that, and I was not really able to see that. So it's my question, or what I feel, because I could not dig it that really, is that it's something which may be shared between different app services. Anybody here using app service? Yep. Are you using that for web only, or yes, web? Anybody's not using it for web? No, everybody. So usually there's no problem because it's the most common case, right? Already. 2 minutes, 47 seconds to make questions. I don't have anything else to give to you. I want questions, come on. So the people using K6, are you happy with it? Yes? No questions?
To set up an environment, you only need to install exe file and here you write code in Node.js and JavaScript.
Yep, that's cool. Yes, already. Yeah, there's some talks that they are using TypeScript, so it's a bit better experience. Just saying, before I forget, in this part, if I view all the repositories, the project which I was doing some talks last year, K6 multi-scenario template. So if you go here to /OSS, you will find this multi-scenario template, which is kind of a ready-made template to implement test, multi-scenario of different kinds. So it's ready for load test, stress test, spike test. And it's also designed for using not only REST, but GraphQL with authentication and logging. Yes?
How are you doing the load test without the Azure provider not blocking? I didn't even try, but I know that it has some DDoS attacks depends.
Sorry, say that again, please.
So I know that cloud providers have DDoS attack protection.
Yes.
How do you do the load test without the cloud blocking?
That's a very good question. Usually, I am not doing that yet at that level, so I'm doing the test internally. That's what I did. That's why I set it up as I did. There are ways to disable that in Azure. You can trust originator, and you have a DOS, you can disable the DOS protection up to a rigs, but you can do that in a test system, right? And That's what I did that directly inside Azure. Make sense?
Yep.
Cool. So I guess you are thinking of doing a very, very large test.
Not really.
Okay, good. So thank you very much. Unless anybody has any question, we are done. And I hope you can save the day. And if you do, you know my Twitter, you know my GitHub. Let me know your story. If this has inspired you, I would really love to hear from you, really. Thanks.